Hello everybody and welcome to Simplified in 5. Today we are going to talk about inline variables introduced in C++17. So let's first see why they are introduced. A quote from cppreference.com goes like this. Because the meaning of the keyword inline for functions came to mean multiple definitions are permitted rather than inlining is preferred, that meaning was extended to variables. Inline specifies when used for a function or variable are a hint for the compiler to replace the actual call with either function body or variable definition. Thus, now multiple definitions are allowed for a function body or a variable to exist, and they are pulled into different translation units whenever a call is made. Multiple definitions, let's discuss multiple definitions in more detail because that's a little trickier for inline variables. By default, an inline definition is valid in current translation unit, that is the header in which the variable is defined, and in all source files where that header is included. But it must be made sure that inline variable is declared as inline in every translation unit if you are going to use the inline variable in multiple translation units. And inline variables have the same address in translation unit. An inline variable must be defined in every translation unit, and that definition must be identical everywhere. So otherwise, if the inline variable is defined differently in different translation units, the behavior is undefined. Let's see how the linkage for the inline variables work. So basically, in inline const variables, when they are within the namespace scope, they by default have an external linkage. But if you declare an inline variable as static, then it's associated with internal linkage. Also, if your inline variable is uh, sorry, if your static variable is constant expression, then also it's implicitly inline variable. Let's see how on or what is the biggest advantage of having static inline variables. Basically, an inline static data member can now be defined in the class itself, and there need not be a separate definition which is out of the class. Thus, inline variables have removed the obstacle of packaging header only libraries in C++. So prior to C++17, it was necessary to have a source file where you will have a body dedicated to defining the single static member variable. Now, but with C++17, you can define the static variable in header, and all the translation units could refer to the single copy from that header. Let's see a simple example like here. So earlier in your my class, if you have a static variables like hello, like string hello or integer I, then in your cpp you have to define them and provide the memory for them. But now with inline variables, now you can make them inline in your header itself, and those variables will be copied, or multiple definitions will be created for them in for each translation unit where of which they are part of. So basically, these are the 5 key things. We saw how to use static inline variables. We saw usage of static inline variables. We saw how the linkage works. We saw how the multiple definitions for inline variables should be used, and we saw why the inline variables are introduced in C++17. So thanks for watching and hope this helps.